Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 3 video where I will solve 3 questions, question number 7, 9 and 16 from exercise 25.1 from the chapter of probability. This is from the textbook of author R.D. Sharma. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 3 video where I will solve 3 questions from exercise 25.1 on the chapter of probability. Okay. The first question number 7 from exercise 25.1 says, a survey of 200 students was conducted to know the opinion about mathematics and following data was recorded. So the number of students who liked the mathematics was 135 and the number of students who disliked mathematics was 65. So obviously the 135 plus 65 should be is 200, and also if you choose any particular student at random, then he will either like mathematics or he or she will, the student will like the mathematics or the student won't like mathematics. So let's say I'm calling L to be that student likes maths and D to be the event student dislikes maths. Now clearly the events L and D are elementary events, meaning that is these two events are the all possible outcomes of a trial. What is a trial? That you randomly select a student and you see whether the student likes mathematics or the student dislikes mathematics. So either the student will like mathematics, which is event L, or the student will dislike mathematics, which is event D. So L and D are clearly elementary events, meaning these are all the possible outcome of a trial. What is a trial? Trial is you randomly select a student and ask and see whether the student dislike or like mathematics. So clearly we must have probability of L plus probability of D should be equal to 1. Let's see. Now what will be, now while solving these problems, I will of course I will of course solve what is asked, but in general I will also try to discuss the concept behind the given problem. So given this data that out of 200 students, so you can consider 200 students to be 200 trials. Now what is the experiment? The experiment is student is randomly selected and asked whether he or she like or dislike mathematics. So 200 if 200 students are asked, you can consider it to be 200 trials, and you can clearly see that out of those 200 trials, 135 trials are favorable to the fact that the student like mathematics. So give me a few seconds. I will quickly configure my canvas. It is not working properly. Where it is. Okay. So clearly, what will be probability L? Probability PL. What is L? That randomly a student is selected and that the student like mathematics. and what is event D? Randomly a student is selected and that student dislikes mathematics. So what will be the probability of L? It will be in the given number of trials, what is the number of trial favorable to the fact that the student like mathematics, that is 135, and the total number of trials was 200. So this is now okay, this will be 0. I think 0.675. No, yes, I think 0.675. Okay, now what will be the probability of event D? That is, you randomly select a student and the student will dislike mathematics. It will be 65 divided by 200 which is 0.325. Now clearly if you add them up, 0.675 plus 0.325 is clearly equal to 1. So these two events L and D are elementary events, and these are all the possible outcome of the experiment. What is the experiment? A student is randomly selected and asked whether the student like or dislike mathematics. Okay, let's see the next problem. Question number 9. 11 bags of wheat flour, each marked 5 kg, actually contained the following weights of flour in kilogram. There are 4.97, 5.05. So there are 11 bags and their weights are given. So find the probability that any of these bags chosen at random contains more than 5 kg of flour. Okay, now actually chosen at random contains more than 5 kg of flour. Now if I consider the event, if I consider E to be the event, randomly selected bag contains more than 5 kg of flour. Now let's try to analyze this problem as experiment. What are the trials and how many number of trials are there and what are the possible outcomes? Okay, so there are 11 bags. There are 11 bags. Okay, now you will see that some of the weights, so the weights of 11 bags are given and some of the weights are repeating, like 5, it is repeating, 5.08 is also repeating, 5.08 is also repeating, 4.98, no, it is not repeating, 5.06 is not repeating, 5.04, no. Okay, okay, so if you want to analyze this problem as a outcome and frequency, then what is the unique number of weights we are having? We are given weights of 11 bags, that is the weight of flours 11 bags are containing. So let's say weight, if I create a table, weight in kilogram and frequency, so the weight of 4.97, how many bags are there? which is containing 4.97 kilogram of wheat flour, that is only 1. So similarly 5.05 we will have 1. 5.08 we will have 2. 5.03 we will have 1. 5 we will have 2. 5.06 we will have 1. I'm sorry, I'm running out of space. 5.07 we are having a 1, and 5.08 we are having 1. So this is basically if I want to convert this given data as a frequency distribution table, this is how it will look like. Okay. Okay. Now clearly, if you add up the frequencies, it should be equal to 11. So 1, 1, 2, 4, 5, 6, 7, 8, 9, 10. Oh, I think I have missed. There is also 4.98. So 4.98, 1. Okay. Now, so okay. So what are the elementary events? Since there are, how many unique weights are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are unique weights. So there are unique weights. There are 9 unique weights. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are, you can say based on the given data, there are, if you randomly select a bag, there will be how many unique weights was there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 unique bags. Okay, so there are 9 possible outcomes of the experiment. What is the experiment? The experiment is that you randomly select a bag and see how much wheat flour it is containing, and so it will the weight will be one of these 9 unique weights. So there are 9 possible outcomes. So let's say I am naming the event E1 to be the fact that a randomly selected bag is containing wheat flour of weight 4.97. Similarly, let's say I am naming the event E2 as a randomly selected bag is containing wheat flour of weight 5.05. So this way there are 9 unique weights. E9 to be the event that a randomly selected bag will contain wheat flour of weight let's say 5.08. So these events, all these events E1 to E9, they are all elementary events, and these are all the possible outcomes. By outcome I mean if you randomly select a bag, the weight of the bag will be one of these weights, one of these 9 weights. So clearly we must have probability of E1 plus probability of E2, this way up to probability of E9 should be equal to 1. I am not doing this, but definitely it will be equal to 1. Now let's see what the problem has asked. Find the probability that any of these bags chosen at random contains more than 5 kg of flour. If you consider the event A to be, we have already considered the event E to be randomly selected bag contains more than 5 kg of flour. This is a compound event. Clearly, we know that a compound event is a collection of elementary event. This will be the collection of, it has asked more than 5 kg of flour. So it can contain 5.03 kilogram of wheat flour. So this was E1, E2, E3, E4. E4 will be there. It can contain 5.05 kilogram of wheat flour, which is event E2. It can also contain 5.08, so it will be event E3. It can contain 5.06, which is 1, 2, 3, 4, 5, 6, event 6. It can contain 5.07, which is event E8, and as well as it can contain a weight of 5.08, which is event E9. So the event which E, which is the randomly selected bag, contains more than 5 kilogram of flour. It will be a compound event, and it is a collection of these elementary events. So probability of E will be equal to probability of E4 plus probability of E2 plus probability of E3 plus probability of E6 plus probability of E8 and plus probability of E9, because all these elementary events will satisfy the condition of the event T. So this is the basic concept of compound event. A compound event is a collection of elementary events such that if any of the elementary event happens, automatically the compound event will set to happen. Okay, now what will be this value? What is probability of E4? Now all these individual probabilities, that is the probabilities of E1 to E9, we have to compute using the empirical formula. So E4 is the weight is 1, 2, 3, 4, 5.03. Its frequency is 1, so it will be 1 by 11. And E2 is the weight is 5.05. It is also, its frequency is also 1, so 1 by 11 plus E3 is also E3 is 5.08, so it will be 2 by 11 plus E6 is 1, 2, 3, 4, 5, 6. E6 is 5.06 weight, so its probability will be 1 by 11 plus E8 and E9 will also be 1 by 11. Now if you simplifying this, we are having 3, 4, 5, 6, 7 by 11. So 7 by 11 is the probability of the event that a randomly selected bag contains more than 5 kilogram of flour. Now I created the frequency table and explained the concept of elementary events and compound events related to this problem just for the sake of discussion. But you could have easily solved this problem orally by counting the number of bags whose weight is more than whose bag is marked, the weight of whose bag is marked more than 5 kilogram, which will be this 5.05, 5.08, 5.03, 5.06, 5.07, 5.04. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 and 5.08, 7. So clearly 7 by 11 would have been the answer. Anyway, so let's see the next problem, the last problem. This is question number 16. Two dice are thrown same time. Same time means simultaneously 500 times, and the sum of the numbers appearing on their tops are noted with the following frequencies. Okay. If the dice are thrown once more, if the dice are thrown once more, what is the probability of getting a sum of 37? More than 10, less than or equal to 5, between 8 and 12. Clearly, we can see that the sum of the numbers appearing on the top of the two dice when they are rolled can never be 37. The maximum it can be is 12. That is what we can see in the given frequency table. So if I let's say I am considering E37 to be to be the event that the sum to be the event that the sum of the numbers appearing on the top of the two dice is equal to 37. So this will be clearly 0. This will be clearly 0 because the maximum, the sum of the numbers appearing on the top of two dice when they are thrown can be maximum 12. Okay, now so part 1 is 0. What is okay, by the way, first of all you must understand that let's say what will be E2, what will be the probability of E2. What is E2? E2 is the event that the sum of the numbers appearing on the top of two dice is 2. This is based on the empirical formula and the given data. It will be 2 by since the two dice were thrown 500 times, the number of trials the number of trials is n is 500. N is 500 and m, small m, that is the number of trials favorable to the event E2 is 2. So the probability of the event E2 is 2 by 500, which is 0.004. Yes, 0.004. Similarly, probability of the event E3 is the event where the sum of the numbers appearing on the top of two dice is 3. Based on the empirical formula, it will be sorry, I did a mistake. And probability of E2, the m is not 2 but m is 14. I'm sorry. The frequency is 14, which means that the number of trials which is favorable to the fact that the sum of the numbers appearing on the top of the two dice is 2 is 14. So it will be 14 by 400, and to calculate this I will be using calculator to save time. So 14 sorry, 14 divided by 500 is 0.028. Similarly, the probability of the event E3 will be 30 by 500, which is 30 by 500 is 0.06. This way we have to calculate. I mean, if it is required, if it is needed, we must be able to calculate all these events. So E12 is the probability of the event E12 will be 15 by 3, sorry, not 3, 15 by 500, and this is equal to 15 divided by 500 is 0.03. So all these events E1, E2, E3 up to E12 are the elementary events, because these are all the possible outcomes. What is the outcome? That is the sum of the two numbers appearing on the two dice are the elementary events. So obviously probability sum of the probabilities of all these events should be equal to 1. Should be equal to 1. And we are asked to find, so part 1 is clear, it will be 0 because the sum of two numbers appearing on the two dice can never be 37. Let's see part 2, more than 10. Now more than 10, okay, so I am considering, I am naming the event that the sum of the two numbers appearing on the top of the two dice is more than 10 by as E greater than 10. So clearly this is a compound event and it will be a collection of two or more elementary events. Now more than 10 means it can be 11 or it can be 12. So basically it is the collection of the two elementary events E11 and E12. So probability of this event will be equal to the sum of the probability of the elementary events whose collection is making the event E greater than 10. So we will have probability of E11 plus probability of E12. What is probability of E11? Okay, so we have to find E11. E11 based on the empirical formula will be 28 by 500, which is 28 divided by 500 is 0.056 and E12 we know is 0.03. So this will be probability that the sum of the numbers appearing on the on the top of the two dice is greater than 10 will be probability of E11 and plus probability of E12. So this is 0.056 plus 0.03. This is 0.086. 0.086. Okay. Part 3, less than or equal to 5. Less than or equal to 5. So let's say I am leaving the event that the sum of the two numbers appearing on the top of the two dice is less than or equal to less than or equal to 5 as less than equal to 5. This is also a compound event, and the elementary events whose collection will make this event are obviously E2, E3, E4, E2, E3, E4 and E5. So clearly probability of this event will be equal to sum of the probability of the elementary events in the collection. Probability of E2 plus probability of E3 plus probability of E4 plus probability of E5. What is probability of E2? It is 0.028. What is probability of event E3? 0.06. What is probability of event E4? E4, it will be, the frequency is 42. So 42 divided by 500. What is E5? E5, the frequency of the sum of 5 is 55. So this will be 55 divided by 500. So this becomes 0.028 plus 0.06 plus how much is 42 divided by 500? 42 divided by 500 is 0.084 And how much is 55 divided by 500? It is 0.11. If I add this up, add the numbers, this will be plus 0.84 plus 0.06 plus 0.028. It is coming out to be 0.282. This is the probability of the event that the sum of the two numbers appearing on the top of the two dice is less than or equal to 5. Part 4 was between 8 and 12. Between 8 and 12. So let's say I am naming that event between 8 and 12. Now between 8 and 12 means greater than 8 and less than 12. So greater than 8, greater than 8 and less than 12. This is also a compound event, and the elementary events and the collection of elementary events that will define or make this event will be the sum can be 9, so E9, the sum can be 10, and the sum can be 11. So this is equal to so probability, sorry, so then probability of this event will be equal to the sum of the probabilities of its elementary events. Probability of E9, probability of E10, and probability of E11. What is probability of E9? The frequency of the sum of 9 was 53. So 53 divided by 500 plus E10. The frequency of E10, the sum of E10 was 46. So 46 divided by 500 plus sorry plus E11. E11 was 0.056. 0.056. So this is equal to 53 divided by 500 is 0.106. 46 divided by 500 is 0.092 plus 0.056. This is equal to plus 0.056 plus 0.106. This is equal to 0. Approximately 198. I hope you understood the way I solved this problem, my explanation and the concept I applied, and also the side discussion that I am doing for solving the problems related to elementary events, compound events, and that the sum of the probabilities of the of all the elementary events is always equal to 1, and how we are understanding the compound event and identifying all the elementary events whose collection is making that compound event. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Stay tuned for upcoming videos where I will be solving 3 to 4 problems from the textbook of author R.D. Sharma, as well as the supplementary MCQ problem book. And I will also try to solve some problem at competitive level, so that you have a good practice of solving problems on the chapter of probability. So these videos are coming soon, so please stay tuned, I'm ending the video here. Thanks for watching, and until the next video, take care and bye.